Hello, everyone, and welcome to Indian Genes. As humans, ever since self-awareness first flickered in our minds, we have been asking the big question about our origins, where we came from, and what exactly is the road ahead. Every society in every part of the world has had an explanation for this, and we sometimes find it hard to be objective about our place in nature. My guest today, Bill von Hippel, believes that in order to prepare for the road ahead, we need to understand our past. Bill is an author and leading voice in the world today on evolutionary psychology. He has studied at Yale and the University of Michigan. He is now a professor in the University of Queensland. Bill has published over 1,000 articles and has featured in the New York Times, USA Today, The Economist, and the BBC, besides other scientific journals and social platforms. Hi, Bill, and welcome to Indian Genes.
Hi.
So, Bill, it's an absolute pleasure to have you here. And The Social Leap. So, this is a book that has had me engrossed for the last few days, and it's absolutely amazing. So, why don't we start with you telling us a little bit about how did this book come about, and what was the motivation for you with The Social Leap?
Sure. I've been a social psychologist now for almost 30 years, and that means that I'm interested in studying how people interact with each other socially, what gives them the kinds of attitudes and preferences they have, that sort of thing. And slowly over time, I began to realize that studying the way we are today only gives us half the picture because we don't really understand why people hold the attitudes they do and why they socially interact the ways that they do. And so I became very interested in trying to dig into our past to get a better sense of where we come from in order to have a better handle on understanding where we are now. And so for about the past maybe dozen years or so, I've been working with colleagues in psychology, but also anthropology, biology, economics, archaeology, to try to get a better picture on our past. And eventually that led to the book, The Social Leap, where I try to tell the story of the last 6 million years of our evolution and how that impacts the way we are today.
Oh, yeah, it's a great story. And I think we'd start at the beginning and then let you walk us through this, and also post that we can talk about what's in store for the future. But I'll leave it to you to tell us a little bit about the book now.
Sure. So the story of humanity really begins about 6 million years ago, which is around the time that we separated from our chimpanzee cousins. And, if you look back on that period of time and the question of why we separate, on the one hand, it seems kind of strange and confusing because at that point, we basically were very chimp-like creatures, and we lived very happily in the rainforest. We were kings of the canopy. And so you have to ask yourself, what would ever get our ancestors to leave the safety of the rainforest, where they're really at the top of the food chain, and move out to the savannah, where the risk of predation by all sorts of animals that were not a problem in the forest? And it turns out that the answer to that question seems to be the fact that it's not that we left the rainforest, but rather that it left us. The Great African Rift Valley in East Africa has been forming for 30 or so million years. And by 6 million years ago, it had caused a sufficient upwelling on the east side of the rift for the land on the east side to have all risen up to quite a high degree of altitude, and as a consequence, the rainforest to basically dry out and be replaced with savanna. So here we have these chimp-like ancestors of ours who were superbly adapted to living in the rainforest, and they, over a long period of time, forced out onto the ground. And by 6 million years ago, that had pretty much taken place. And so the story of humanity is really the story of what happens next, how we deal with these very difficult new situation of dangerous predators, and at the same time, the loss of the kinds of things that we used to eat. So that's the story that I try to tell, at least in the first part of the book.
And you've done it brilliantly well, I have to say that. And getting back to Bill, you mentioned about this tectonic activity that was the reason that the chimps first moved out into the savannah. Would this be something similar to what happened in Java, Indonesia? Because I think there's a similar story there as well, because the West Islands appeared about 7 million years prior to the East, and that is where we finally found the Java man, and there's a lot of story there as well. Is that disconnected to that particular activity?
Yeah, that's a great question. So the tectonic activity basically occurs all over the Earth all the time. And what you've got is all the continents lie on an underlying mantle that's kind of got the consistency of road tar. So you can have a current in it, although of course it's a very slow current. The Indian subcontinent is being pushed by that current into the Asian continent and creating the Himalayas, the upwelling of the mountains in that area. And so sometimes you have two continental plates crashing into each other, like you have in that case, and sometimes you have continental plates tearing apart. In the case of Africa, it's tearing apart. Now, I have to admit, I don't know what the tectonic activity is going on in Java. It would happen entirely separately, though, because, of course, all of these plates move around of their own volition, sometimes crashing together, sometimes tearing apart. The interesting thing for Africa is just simply by virtue of the currents that underlie the plate in the underlying mantle, the Africa will eventually be torn into two continents.
Right. And I think this is the same activity that would have had the Himalayan range move up and could be the cause for that, right?
Exactly. In that case, you've got the two continents crashing together rather than tearing apart.
So to set this up, Bill, I would just like to get back to the beginning and get a little bit of a deeper understanding here, because you say that approximately 7 million years ago, that's when we all had a common ancestor. Is that right?
Mm-hmm. That's right.
Once this movement happened outside, the question then, how did that progression go phase-wise? As in, okay, we do have the movement into the open areas, but what happened next?
Once that took place by 6 or 7 million years ago, and those chimpanzee-like animals, they're not quite exactly like today's chimps, but very close. We'll call them chimps. Those chimps that lived on the east side were now forced down onto the ground, onto the savannah, and the chimps that lived on the west side of the Rift Valley could continue life as they had before. So what happens to the chimps on the east side? Well, my guess is that if you replayed that scenario 100 times, imagine you're lord of your own planet and you can just roll the dice and do it over again, you would probably lead to a bunch of extinct chimps, or you would lead to chimps that are really just living on the margins of the savannah in the shadow of the apex predators that used to be irrelevant to them. But somehow we got really lucky. And instead of leading to that terrible outcome, it led to us. And so our story is really how that came about. And what we believe based on the fossil record is that for at least the first 3 to 3.5 million years, you've basically got our ancestors doing exactly that, living on the margins of the savannah, always keeping a very close eye on the trees, and living much as today's chimps do when you actually find situations where they're living in the savannah, which is really being quite fearful and avoiding open spaces where they could be attacked. But by 3 to 3.5 million years ago, we had now evolved into Australopithecus afarensis. And now we know that these ancestors of ours were bipedal. That is, they walked upright. And by virtue of being bipedal, everything changed about the way their body was shaped. And that led to a really important change in the way that we lived our lives, which in turn rapidly led to the evolution of us.
And at this time, the Australopithecus would have stayed in Africa, but we do have theories where this movement out of Africa into Asia, Southeast Asia, and Europe happened. So is this also a time when one of these species moved out?
Well, so the moving out was predominantly later. Australopithecus, we're now looking at 3 million years ago or so. By that, we're moving out around 1.8 million years ago as Homoerectus. And so once we evolved around 1.9 million years ago into Homo erectus, which was a couple of stages away from Australopithecus, now we see evidence of them leaving Africa in large numbers. And as you note, moving into India, across Asia, all the way over to China, and as well moving over into Europe, all the way across to the edges, even all the way up north into areas like England and such. And so you've got massive departure from Africa of some Homo erectus, but other Homo erectus, for random reasons, obviously, choosing to stay in Africa. And Homo sapiens are the offspring of those Homo erectus who stayed in Africa. Neanderthals are the eventual offspring of those Homo erectus who left Africa.
Brilliant. And is there any reason why the Australopithecus would have held back for that period of time, if you say 1.5 million, and would not have moved out of Africa and waited, for some time? Is there something that held them back?
Well, Australopithecus was at a much smaller brain than Homo erectus. They were much closer to a chimpanzee. And so they didn't have the capabilities of being such a flexible species as Homo erectus. They weren't as capable of making their own tools. They weren't as capable of social organization. And so it's very possible that they simply couldn't make a go of it. That if they got too far north or if they traveled too far, the circumstances were too unfamiliar to them. And so in most animals, we see rather restricted home range. And humans are unique in that the whole world is our oyster. We don't have restricted home ranges. And Homo erectus was most of the way toward us. They colonized most of the world that they could access. Not all of it. They didn't go quite as far north as they could have. Not as far north as Homo sapiens went. And so what's probably underlying that effect is the advanced intelligence of Homo erectus compared to Australopithecus, and then our advanced intelligence compared to Homo erectus.
And would it also be with the Homo erectus, or with that particular species is when we first found out that we tended to move towards meat eating, because there is some proof of eating meat or meat in our diet started with Homo erectus?
Yeah, well, eating meat has been in our diet since we're chimpanzees. But as you point out, eating meat became a lot more important with Homo erectus. And the best evidence you can see for that is if you look at the other great apes today, gorillas, orangutans, or chimpanzees, and then you compare them to us, you'll find that they have a very large gut that supports a very small brain. And we have a very large brain supported by a very small gut. You can see that most notably if you look at the rib cage of humans compared to the other apes. Our rib cage is aimed pretty much straight down because there's not that much gut inside us, and their rib cages bow outward. If you look at Astrilopiticits, their rib cage still bows outward, much like a chimpanzee. But by the time we get to Homo erectus, our rib cage is much flatter, suggesting that they too could support a large brain with a small gut, which suggests that they must have been eating much higher quality food. And of course, meat is much more calorically dense than plant material. There's more fat in animals if you're eating animals, and as a consequence, you can support a larger brain with a smaller gut.
Does that also mean that this is some proof of us moving from probably into hunting, gathering now rather than just scavenging? Because the amount of meat that has been detected in some of the fossils does show a big increase in this. So does that mean that we could place hunting to somewhere around the Homo erectus time?
Yeah, so what it probably suggests is that although even chimps do hunt, they do so very occasionally. Hunting had become much more common by Homo erectus, and probably was a mainstay of our diet was hunting, just like it's a mainstay of modern human hunter-gatherers. And so it is the case in modern human hunter-gatherer societies that there's still lots of gathering that supplements hunting, because gathering tends to be more reliable, gathering of vegetable materials, plant materials, but nonetheless hunting is an important everyday activity in modern human hunter-gatherers, and probably, as you say, these data suggest that it was an important everyday activity among Homo erectus. Some people have argued that they were mostly just scavenging. I don't find those data very compelling, in part because we often see the marks of Homo erectus's stone tools on the bones of animals way up on the thigh.
Right.
And when you look at animal kills, they always consume the thigh very early in the kill because there's so much meat there. And as a consequence, if we were scavenging, we would not be bothering to chop away at the thigh because there'd be nothing there but bones. We would be working down by the ankles, up by the face,
Right,
in areas that are left for last by predators.
Absolutely. How do you differentiate between species and genus before we move forward? Because we sometimes tend to use the word species, we then talk and we move to genus. So is there an easy way for my listeners to figure out what this, or in their minds, how could they hold this easy?
Yeah, so I think the easiest way to think about it is, so we're Homo sapiens. Sapiens is our species label and Homo is our genus label. And so there are several Homo species, Homo sapiens, Homo erectus, Homo habilis, as we work our way back. The final word on there is our reference to our species.
And is there any current living animal that you can point to that has a combination of both?
Well, all Homo sapiens, that is humans, who left Africa also contain Neanderthal genes. And that, of course, is a different species. And the reason we contain Neanderthal genes is that we interbred with them in Arabia and again in Europe and on our way toward China. And so if you look at our entire genome, you can find Neanderthal genes scattered about even in modern humans. And so, like all species, there's nothing pure about us. We're a combination of all sorts of genes. Some of them are consistent with chimpanzees, some of them are consistent with more recent relatives like Neanderthals, and some of them are consistent with celery, with plants, with things that are very distant from us on the evolutionary tree.
Interesting. Yes, definitely the Neanderthal, and I would want to come back to that a little bit later. Also, I would just like to put a little bit of timeline here, and you can correct me if I'm wrong, because the fact that we're talking about 2.5 million and 6 million and 8 million, the tendency for people to think in time and space is, how was it possible for somebody to walk from, let's say, East Africa to Java, where most of the other fossils are found? And I think that there is a pretty good explanation for this within this time scale, because I think the accepted norm is that these particular species would have moved at about 10 miles a generation, is what the hold now is. And at that speed, they would have covered this distance from East Africa to Java which is about 6,000 miles in 15,000 years. And that is nothing compared to the timescales that we're talking about.
Now, that's a very good point. And so often when it's so hard for us as humans to think in terms of millions of years, when our entire life takes place in less than 100 years, and 10 years seems like a long time to us. Right. And it is very important to remember that people are just walking, that the speed at which you walk and cover ground is going to depend entirely on how afraid you are and want to leave where you were, or how motivated you are to get to somewhere new. And so people would have traveled at different speeds, but it was always at walking speed. And so most people spent their entire lives in terrain that was very familiar to them, even if they spent their entire lives moving. Even if they're nomadic people, which basically they always were, nomads often wandered over the same territory, but they often went in a particular direction.
Right.
So we know that the first signs of Homo sapiens out of Africa are in the order of 100,000 years ago, but we don't see them leaving Africa in earnest until about 80,000 years ago, and we already see them in Australia by 65,000 years ago. So under the right circumstances, it's a long period of time, but people can cover a lot of ground.
And when we talk about this period of time and we connect it to evolution, and this is the process that is taking place, in hindsight, we could think of it as a continuous linear progression where everything leads to a particular end. But my thought is, I'm not sure whether evolution works that way. It probably is happening in the moment for now and leads up to certain outcomes rather than starts off with an end in mind.
That's exactly right. Evolution has no end in mind at all. And so all it does is it works with the traits that you already have. And as a consequence, sometimes we end up stuck with some very poor designs. So for example, the human eyeball has a blind spot because of the way the nerve is connected, and it has a lot of vascular material, blood vessels between the back of the eyeball and the outside world. You would never design blood vessels between what you're trying to see and the receptors for seeing them. But we happen to get started on an eyeball that had the vascularly that way, and of course then we're stuck with it. An octopus has an eyeball that makes a lot more sense.
Right.
All that material sits behind it because it started with a different eyeball. And so evolution, all it does is it randomly has things. When those things are good, whoever owns them is more likely to survive and therefore more likely to reproduce. And then those traits get passed on. If you have traits that are not good ones, that don't suit your particular species, they may be good for other traits, but they're not good for you as a human or whatever you are, well, then you tend not to survive and you tend not to reproduce and they tend to disappear. So evolution doesn't think forward at all. It only operates what you have now and as a function of whether it's useful today. If it can't think of to be useful tomorrow.
And these traits that you talk about through genetic mutations that move forward, it also would tell us that the environment would have very big impact because it's just not genes. It depends on things around you, the climate, the weather, for example, the social structure of where you are at that time, because the environment has to support it or the genes has to support the environment. I'm not sure what comes first, but I would think both go together.
I would agree with you completely. They interact with each other. And when we do the genetic work on most complex human traits, we find that they're about half genetic and about half attributed to the environment. And so what that means is that you can predict how tall or smart or friendly you're going to be. About half of it is your genes, half is your environment. But the key is what's really predicting is that ongoing constant interaction between gene and environment, because genes require the environment in order for them to be expressed and for them to direct your behavior in different ways.
Yes, that totally makes sense. And if we had to move forward from here, Bill, and we have found a lot of toolkits and stones. So how would you place this into as far as the Mobis line is concerned? So when we talk about the Mobis line, we do talk about there is a difference between the kinds of hunting instruments that were used at that time. Would you like to give us a little bit more about that?
Sure. So if we go back far enough in time, we see some stone tools that somewhat start the earliest ones. People argue about exactly how old they are and what they were for, but really all they are is sharpened stones. And they're on the order of some arguably as old as 3.3 million years ago,
Wow.
Which mean that Astrilopiticits was sharpening stones. Now, chimpanzees use stone tools, but they never sharpen them. And so that would really, it seems trivial, but that's a pretty big step. From those early Lomekwi tools, we then moved to Oldowan tools, which are much more widely distributed, and their existence is a lot less controversial. And now we're on the order of 2.5 million years ago, even a little older, and those tools can be found all over the place. And so they clearly were very useful for ancestors. They were in use and basically remain unchanged for over 1 million years,
Right.
Meaning that once our ancestors, Homo habilis in all probability, arrived on that design, it was useful for them, so they stuck with it. And it seems to be the case that they made them and then used them wherever they are made. So they're probably, when you're hunting or when you've already got a kill and you need stones to dismember it, you sharpen them up in that way and you use them. the fact that they were sharpening stone tools strongly suggests they were probably using sticks as spears and things like that as well. Because we even know chimpanzees, at least the ones who live in the savannah in Senegal, will use their teeth to sharpen branches and then use them to stab monkeys. So in all probability, our ancestors were doing the same thing. But of course, a stick isn't going to survive for millions of years in the same way as stone will. So unfortunately, we're limited to looking at those aspects of their toolkit that have still survived. But you can virtually guarantee that they were sharpening stones, that they were sharpening sticks, in all probability using animal bones and animal hides as well, both for shelter and for tools and hunting and that sort of activity. And that would have been going on for millions of years. Now, every so often they improved on it. And so when we get to Homo erectus, they now develop Acheulean tools, which are much, much better tools than the Oldowan tools that they inherited from Homo habilis. And they're really the first tool that you could recognize yourself without an expert's eye. If you were wandering along and you found one, you would instantly say, wow, there must be human agency behind this tool. It's clearly been designed. Whereas you could literally pick up an Oldowan tool, and if you're not an expert, skip it across a lake without ever knowing you held an object of any significance.
And is there any reason why the Acheulean axe, for example, or the Acheulean tool, was more common with the African apes or on that side of rather than the Asian apes? Because when I say Asian apes, I mean the species in Asia, because probably it was the climate or the need not to have them, or it split somewhere?
Well, what's interesting about Acheulean tools is that they exist both inside and outside Africa, but yet they weren't developed by Homo erectus. So remember, the Homo erectus is now our genus. It's Homo.
Right.
So thinking of them as apes is probably a little bit inaccurate because they look more like us than they look like a chimp or something.
Right.
But they developed those tools after they had already left Africa and colonized Southern Asia and Europe. And so they developed them outside Africa as well as inside Africa, and they look much the same. Now, it's impossible for us to know how much of that's transmission of ideas and how much of that is people arriving at the same solutions in different sites. But given that they seem to have arrived at that basic solution pretty much everywhere, and then they kept that basic solution for over 1 million years, suggests that it was probably a combination of communication and also of convergent evolution, so to speak, arriving at the same solution because it's simply the best one that you can do with your mental and physical capacities.
Absolutely. And I think this probably is also the time in that case if we come into the, at least my favorite part of your book, or the hypothesis of the throwing theory, where I personally think that things change the moment we develop this ability to throw. And I would leave that to you.
So the throwing hypothesis is really a fun one, and it's been around for about 40 years, and I think it does a great job of explaining how everything changed. So if you recall, a little while ago, we were chatting about Australopithecus afarensis and how she became bipedal and therefore was standing upright and walking on two legs. And although a chimpanzee can also walk on two legs, when it does so, it can't lock its knees and it can't straighten out its hips entirely, and so it's a very inefficient walker on two legs. By the time we get 3 million years later to Australopithecus, we now have good evidence that they're standing straight up and their knees lock and their hips can go straight. And we can see that in some footprints that were fortuitously made by Australopithecines in some ash in Africa, the Laetoli footprints. And as a consequence, they've been analyzed and you can mirror them by walking in different ways, and you can see quite clearly that the way they're made and the weight distribution means that you were locking your knees and your hip.
Is that the Lucy footprint? Or
Yes.
Okay.
Yes, that's Lucy's footprints.
Yeah, right.
And so Lucy's so named because Lucy in the Sky with Diamonds was a popular song when they were digging up the best specimen. So, or at least the best one at that time. So once you get to bipedalism and you can stand up and you walk upright, what happens is your waist tends to lengthen out and your shoulders and arms and wrists become more flexible because you're no longer using your arms as a way to hold your entire weight anymore, like a chimpanzee would be in the branches. And so their arms have to be more stable than ours. And their hips are narrower because they're not standing straight up and they're not walking the same way we are. So the end result of that is by lengthening out our hips the way we did, they become more easily rotated. And by no longer going up and down trees all the time, our musculature starts to become more laterally oriented toward the world by things side to side rather than things up and down. And fortuitously, not by design, but just as an outcome of all those bodily changes, now throwing becomes much more possible. So if you watch people throw like on a beach or something, they just use their arms and shoulders. But if you look at proper throwing by a cricket athlete or a hunter-gatherer, it's a full body motion. And it typically starts with the opposite leg, and that goes forward, and then the hips start to rotate, and then the shoulders start to rotate, and then the elbow comes through, and the very last thing that comes through is your wrist with a flick of the hand. And when you do that, you generate enormous elastic energy across your muscles, ligaments, and tendons, with the end result that it's like a snap of a rubber band. And as a consequence, once you become bipedal, you can throw much better than you could throw if you were a chimpanzee because they don't have any of these qualities. Their ligaments and tendons and muscles won't align that way because they're simply too inflexible. So when they throw, they typically have to do so with two hands overhead and don't generate much force or power or accuracy either. And so the end result is that coincidentally, as a byproduct of bipedalism, Australopithecus now developed the capacity to throw. And as you point out, that's an enormously important invention because it allows you to kill at a distance. The military historians regard that as the single most important capacity military invention in history. Because if you think about it, only when you can kill at a distance can a larger force of weaker individuals successfully attack a smaller force of larger individuals. And just by way of example, imagine what you would do if you and 100 friends decided you needed to kill a lion and you were only armed with knives.
Absolutely.
Well, you could do it, but you'd be in a huge argument about who goes first because you know that whoever approaches that lion first is going to get killed. So second, third, fourth, and fifth in all probability. And so no one is ever going to approach it because they know whoever goes first is going to die. But if you can throw, if you can attack the lion at a distance where it cannot counterattack you, now suddenly a large force of weak individuals can do so from relative safety. And that's why we get everything changing when we get to Australopithecus, because suddenly they have this new weapon at their disposal. And the key is that that new weapon requires that they cooperate. Because one Australopithecus throwing stones, even if he's a great stone thrower, simply can't stop a leopard or a lion. But 30 or 40 of them could. And so now for the first time, there's enormous pressure on them to cooperate with each other in such a way that if everyone cooperates, everyone is better off. There's no losers in that game. If you all break and run for the trees, someone's going to die because the lion is faster than you are. But if you all stand your ground and throw stones at it, no one's going to die. The lion's going to have to run away. And that was the big change for our ancestors that led to where we are today.
Great, very interesting. And I think we do have proof of this with somewhere in Jordan, if I'm not mistaken, with the remains of an elephant from that time. And from the looks of it, it looks like the Australopithecus got together and there were people who were individually doing tasks to get the elephant down or post getting the elephant down to control it.
Well, that's a little later on. So not Australopithecines anymore. Now we're back to Homoerectus again.
Right.
But you're right. Yeah, you're right, though, that we've got interesting evidence out there that's strongly suggestive of division of labor, of working together, to using these Acheulean tools to trap and butcher or kill and then butcher an elephant. In all these cases, there's always some ambiguity, right? We can't know for sure that elephant wasn't very sickly and ready to die. We don't have the information that we need because all that we have left are the bones. Right. But when you add up all the data we have together, it's strongly suggestive that by the time we get that from Australopithecines, in all probability, the inventors of the throwing to Homo erectus, who now his body is fully in shape for an animal who should be a very effective thrower, right. It seems highly likely that we're using that as a hunting tool and not just a tool for protecting ourselves.
Absolutely. And I think even psychologically, we would have realized for the first time that not only can we collaborate to kill at a distance, but we have control over our environment at a distance. But looking at it from the other side, I wonder, it probably would have been different for the other animals as well to suddenly realize that there is this one species who now can attack us at a distance. So I think it's both ways.
Yes, it's always the case that life is a coevolutionary struggle. You're absolutely right. And so what would have happened, my guess, of course, we weren't there to know,
right.
But my guess is that lions, leopards, hyenas, saber-toothed tigers even, who existed at that time, would have attacked our Australopithecine ancestors willy-nilly without thought.
Exactly.
And then over time, as they developed the capacity to kill at a distance and they moved from there to Homo habilis and eventually Homo erectus, who were very effective at killing at a distance, all those animals would have started keeping their distance from us and no longer hunting us in the same way that they had before, because those animals who were inclined to hunt humans would end up dead. Those animals who were, for whatever reason, randomly disinclined to end up hunt humans would have had a much better chance of survival. And so again, as you point out, we were then in evolutionary pressure on the other predators on the savannah.
Absolutely. And would this also be the time then, Bill, where we get into the development of the brain and you look at this movement from 420 or 380 to our brain finally doubling and then going on to the Homo habilis and then as we move forward to Homo sapiens, there has been this progressive, because I think it's about 385 cc for a human baby today born. So how did this progression happen?
Yeah, that's a great question because it is tightly intertwined with this. So if you look at the size of a chimpanzee brain, it averages about 380 grams. And then you wait 3 million years on the savannah right. And you get to Australopithecus and all you are is at 450 grams. Oh, they've only gained about 70 grams of brain after all that time. And then the question is why? Why did it gain so little for so long and then suddenly take off? Because now, only 1.5 million years later, you've got Homo erectus with a 980 gram brain,
Exactly.
which is more than twice the size. And then, of course, another 1.5 million years later, and you've got us with a 1350 gram brain, again, adding an entire chimpanzee brain on top of a Homo erectus. And what it suggests is that once we started cooperating and working in groups, now there was a good reason to have more brain, because more brain brought us more positive outcomes. The way I think about it is, imagine that you're a zebra and you're as smart as Einstein. Well, what good would it possibly do? You could have interesting conversations with other zebras, but you're still eating grass for a living. You still got hooves. There's nothing to be gained by it.
You're burning extra fuel for no reason.
Yeah, exactly. You can't pay the rent on that enormous brain. So it is the case that a chimpanzee with hands and working together somewhat has reason to have a larger brain than a zebra, and it does. But again, too large of a brain, how's it going to pay the rent on that? And so it's not till we get to Australopithecus and their capacity to start working together by cooperating in their own defense that we see our brain size start to take off and go so rapid expansion. Now, if you look at the underlying genetics, of course, we don't know that much about it yet, but there was a very interesting pair of papers that came out just over a year ago where they noted that there was a gene, the Notch2NL gene.
That's the duplication, right?
That's right. And that gene, I don't remember exactly, but about 12 million years ago, it appeared in our line as an accidental duplication of itself, and then the duplication shut itself off. And this is a way that evolution often works. When there's a duplication error when the DNA are replicating, and you end up with an extra copy of a gene, because now you can mess around with that new gene without screwing up the function of the older one, because it's still doing its job. And so that gene literally sat on our line for, I don't remember exactly, but let's call it 9 million years before it turned on again. It duplicated and turned on again about 3.5 million years ago, around the time of Australopithecus.
Wow.
Why would it happen just when it was its most use? Well, it probably didn't. It probably happened many, many times in between. It's just that every time it turned itself back on, in between that 9 million year period, it was of no use to have an extra large brain. But when it turned itself on in Australopithecus, it caused our neurons to remain as stem cells for longer, which caused them to develop into more neurons before they specialized. And as a consequence, now the offspring of Australopithecines start to have larger and larger brains. But now, for the first time, they can pay the rent on those larger brains by being more effective hunters. And so I suspect that duplication error and replication appeared many times, but it just didn't stay in our line until it was actually useful.
But could that also mean, Bill, that we do currently have a duplication that is lying dormant and is not switched on as yet? So that also tells us that who knows what's going to happen in the future, because we could have the activation of something that is duplicated now. Is that possible?
Oh, absolutely. The thing is that what you have to ask yourself is, what are the forces on humanity today that lead you to have greater reproduction? Because survival is not as big of a deal anymore with the advent of modern medicine.
Right.
And so things that make you more likely to survive because you're a better hunter, they don't really matter anymore. Hardly anyone hunts for a living anymore. You could go into an office, even if you're not really strong, you could make a great living being a programmer or something else. And so there's so many ways to make a living and so many medicines that you can take if you are struggling to survive, that really what it comes down to going forward is how many children you have.
Exactly.
And so if there's a mutation in our genome that leads people to want to have more children, or to, for other reasons, have more children, those are going to be the kinds of things that are more common going forward.
And speaking about children, I think this also, where we stopped last in the progression with the larger brains also means that would have had a direct impact with bipedalism, of course, on childbirth, because I would assume that nurturing and protection and, you get into extended childhood because of exactly that. So would that also be the reason that we evolved a little bit differently emotionally? Because you now had a child that for the first few years was very dependent on the parents or the mother in the case at that time.
No, that's exactly right. And so we're in a situation now, once we get to Homo erectus and particularly Homo sapiens with us, where you develop such a large brain in order to take advantage of your group living and to work together effectively and have division of labor. You develop such a large brain that you've got way more neurons and synapses in your brain than you have genes to guide them. And once you're in that circumstance, then your brain, it can't be born knowing things. It has to relinquish control of knowledge to the environment, which means that you have to be born knowing almost nothing and then learn it across the course of your lifetime. Now, for a brain as big as ours to do all that learning was then going to require a very long period of development. And so the evolutionary pathway that we took, this sort of cognitive niche that we created and then filled, meant two things. One, that childhood is going to have to be much longer because it's so dependent on learning. And two, that we're really relinquishing genetic control over the material, the thoughts in our minds. We can have genes have an influence, but it can no longer control things anymore because we simply don't have enough genes to do that. We have in the order of 1 trillion synapses and only billions of base pairs in our entire genome, much less in the genome that guides our brain. And so the upshot of all that is that the environment starts to become much more important. And you can see this very easily if you look around the world and you look at all the different cultures that we have and all the different ways that they make a living and the different ways that they solve their problems and the different types of beliefs they have. That just shows you the power of learning in the environment.
With all this learning, we would have developed, we come down to a very important part here where we're talking about specifically, I would like to look at what happens with memory here, because I think this becomes very important for us to realize that for us to move forward from here, there would have had to have been some enhanced memory ability for us and it had to be balanced because you need to remember just enough to move forward to the next day and forget just enough to forget the previous day. But probably there are certain skills that would need to be carried on. And, that would become important is how do you start now at that moment or at that time in history, figuring out what was important to remember and what was not. Because like you said, if you get into tool making, I think, did they have the ability to know that, or could they predict the future? Do I need a tool tomorrow? Or does it happen randomly that, okay, I come across a difficult situation today? Because I think as humans now, ability to, one is understand ourselves, understand others, and then predict behavior is a very important part of what we do. So did they have the ability to do that at that time?
Yeah, so our distant ancestors could not predict the future. They couldn't cast their mind forward. And so all they could imagine is a future where they felt the exact same way they feel now. And we can see that evidence, for example, in the Oldowan tools were never carried at any great distance from where they're quarried and made. But now if we look at the Acheulean tools that Homoerectus invented, we can see them carry great distances. And that suggests that our Homoerectus ancestors for the first time thought, you know what, I'm going to need this tool again tomorrow. I'm going to bring it with me rather than, well, I've used this tool, I'll never need it again, because they simply can't envision a future that contains needs they don't currently have. Now, when we look at this in children or in great apes, chimpanzees can't do that. They can't envision a future with unfelt needs. And small children, of course, can't do it either. But by the time kids get to 4, they start to become much more future-oriented.
All right.
Now, then to come back to the other half of your question, memory, of course, is critically important, but an enormously important part of memory is collective memory. And the fact that as a group, we can remember things that our ancestors learned. And the reason we can remember those is we have such extraordinary communicative abilities that people can tell each other stories of what happened. And so every generation of humans doesn't need to start back at ground zero. We can have all the knowledge of our past generations that are shared with these oral traditions and stories that have been told for countless millennia. Whereas chimpanzees simply can't do that. So their culture never moves forward. It never ratchets on the previous generation. It always starts over. And our culture, small school children today learn what only geniuses knew in the past.
Absolutely.
Because all the things that our ancestors have learned, they become part of our oral tradition. They become part of stories. And now in today's world, they, of course, also get written down. And so it's the collective memory that's really so critically important.
And for this collective memory to actually be put into play or for us to benefit from that, I guess the Homo erectus would have understood or realized the importance of collaboration, because collective memory would have led to that, where, we need to now start working together, like you said.
Mm-hmm. Absolutely. And so it seems very clear that Homo erectus understood the power of the group and probably started having this ratcheting culture, but it really took off with human beings. And one way to see that is that, again, the Acheulean tool that Homo erectus invented stayed basically unchanged for a million and a half years to Homo sapiens, where when you see one invention, you immediately see a proliferation of related inventions. And what that suggests is this exact ratcheting process. I invent a very crude bow and arrow, you see it, you improve on it. A generation later, somebody else sees it and improves on it still. And so there's always working forward rather than starting over again. And in Homo erectus, we don't really see that. We see one tool, admittedly a very effective one, but it's staying much the same. Now, like I said before, they may well have been more inventive with sticks that they created spears from and animal parts, and we don't know because they didn't survive the test of time. But the data suggests that they were far less inventive than we are, which again suggests that their culture didn't ratchet as effectively as our own, probably because their communicative abilities were not as strong.
When does fire now start to have an impact on us? Is there some way that we can place where we started controlling fire, and how did that happen?
So Richard Wrangham very well-known anthropologist at Harvard, has argued that the control of fire happens very early in the evolution of Homo erectus. And his argument is based on the fact that when you cook food, you release the nutrients from it much more easily. And it's much easier for you to digest. It takes less energy. And so if we go back to this notion that Homo erectus has a pretty flat rib cage, that means that they have pretty small gut. And one way to have a small gut is if you have fire, because now you can get the nutrients from cooked food with a lot less energy than you could from raw food. You can sort of envision that easily yourself if you just have a steak and sniff it when it's raw compared to when it's cooked. It smells so much better when it's cooked simply because that's evolution's way of telling you, wow, there's lots of accessible nutrients here, lots of accessible calories. And so he's argued that it goes all the way back. Now, when he made that argument, it didn't seem to go nearly that far back. But since then, there's been discoveries that now push back the control of fire to at least 1 million years ago, where we can see in the sediment in caves in South Africa, repeated use of fire over and over that suggests that they were capable of controlling it, moving it, having it in a cave where, of course, it won't naturally start on its own. And so we don't know exactly what they were doing to control it, but nonetheless, it suggests that they were able to keep it going for a long time and use it for purposes of cooking almost assuredly.
And it's interesting, I don't know if you're aware of this, but what was happening at the top end back home in Australia for you, where apparently the black kites, the whistling kite and the brown falcon, they've been picking up twigs from forest fires and then carrying those twigs, the twigs on fire, and then trying to entrap other animals or create a fire around them. And that's very interesting if a bird is actually doing this. So I don't know if you're aware of this phenomenon.
Yeah, I've heard of this. I've not seen any of the data, but I have heard about it. It is super interesting. In the case of Australia, humans have now been here for at least 65,000 years, and Aboriginal Australians use fire a lot in their hunting and the way they interact with the land. And so you could imagine a behavior like that having evolved since humans arrived, when other animals are exposed to fire a lot more often and therefore have a chance to develop this behavior compared to animals where fires are started much less frequently because they're only coming about by virtue of lightning or whatever.
What I'd like to do, Bill, is I'd just like to hold here for a moment and try to, for our listeners, try to get back to where we've reached and what exactly happens here, because we've moved on to the Homo erectus, and also an interesting time probably for me to ask you about the phenomenon of the missing link, because this is very popular and a lot of my friends that I've been speaking to as well, and they talk about the missing link. And we need to understand that there is no such missing link, because I think it was Eugene Dubois who probably in 1887 came up with this fact of trying to go out and look for the missing link, where he moved to Indonesia and that went off and he found I think it was called the Java Man. And we then realized that there actually is no missing link as of today, right? We've got everything covered.
Well, here's the way to think about it. It depends in your mind what exactly is a missing link. So are you looking for one species that has a brain that's halfway between a chimp and ourselves? Right. Are you looking for one species that has a hand or a foot that's halfway between one animal and another?
Right.
And what we found originally, the fossil record was very impoverished because, of course, it's hard to find these things. And in the meantime, we found not just one fossil between us and them, but hundreds of fossils between us and them, thousands of fossils. And these thousands of fossils spread relatively evenly across that time period, but of course the more recent ones are easier to find. And what that suggests is that there's lots of subtle gradations that obviously took place going from an animal that basically was a chimpanzee to us today. And so people talk about a missing link because, of course, you could redefine that missing link anytime you want. Imagine, if you will, think about the space between a chimpanzee brain and ours as being one of, we'll call it a kilogram, because that's basically what it is. And so you'd say, well, we need to find a brain that's halfway between, that's a half a kilo off both of us. Okay, we found that. And they say, well, we still have a missing link. We need a brain that's halfway between that halfway point in us. All right, we found that. Okay, we still have a missing link. And you could keep calling them missing until you get every gram represented and you've reformed that entire continuum from them to us. Now, of course, we haven't reformed that entire continuum from them to us, but we've got so many pieces in that puzzle that you can have a lot of confidence that not only do we have that process represented really well, but also eventually we'll even find some of the missing ones that go in between the pieces that we don't currently have.
Bill, this probably is a good time to touch on the evolution of the social mind, and you have covered that in your book.
Mm-hmm.
So once we develop with the social mind, we do then talk to each other and we say that there are certain things that we've inherited from the past, or there are certain behaviors that play out to us today. And those could be related to the way we deal with each other, the way we interact, the way we talk to each other, behaviors, whether it may be guilt, whether it may be jealousy, whether it may be somebody who's just, we're just full of ourselves.
Sociality interacting with each other introduces all sorts of new interesting problems into the mental sphere. And of course, part of the reason we became so smart was we gained things by cooperating with each other. But part of the reason we became so smart is that as we start to cooperate with each other, we're introduced all sorts of new problems. As we start to try to envision, well, others going to interact with me. Will this behavior that I'm about to engage in be helpful for me in the context of a group or unhelpful? So, if you're a wolf, your goal is just eat as much as you can, as fast as you can when you get a kill.
Absolutely.
If you're a human and you do that, maybe other humans won't like you anymore. And so they won't invite you out on a hunt and stuff like that. So it introduces all sorts of complexities. And an example is one that you were talking about, where we actually learn to gain what are called self-conscious emotions, where we feel toward ourselves as others would feel about us if they knew about our behavior. So when we do something good that would increase our value to our group, we feel pride. And that pride is a reflection of the positive emotions that others would feel toward us. And it motivates us to do those things again. If we do something that devalues us in front of our group, that would make people in our group think less well of us, we feel shame. And that sense of shame makes sure that we avoid those behaviors and certainly don't repeat them again. Similarly, if we do something where we betray a member of our group, where we reciprocate or don't effectively cooperate with somebody who matters to us, we feel a sense of guilt. And again, that guilt is the same as the reproachment that they would feel. They'd be reproaching us if they knew what we had done, but we feel that punishment toward ourselves. And then, of course, importantly, we can envision all of those emotions in advance. So I can say to myself, boy, if I successfully achieve this hunt, everyone will like me more and I'll feel proud. If I steal all the food and eat it myself, everyone will be angry with me and I'll feel ashamed for my gluttony. We can envision the consequences of doing those things and therefore guide our actions toward things that our group will approve of and guide our actions away from things that our group won't like, because that would have been super important for our ancestors. Those ancestors who the group got sick of and tossed out, they're not our ancestors. Things didn't work out for them and their genes would have ended with them.
And I think you've covered this really well in one of your papers titled Evolution of the Social Mind. And I have to tell you that I've been going through those notes as well. And it is available online. So if anybody is interested into reading further or getting to know a little bit about this and the social mind, I would encourage them to find these papers online. Thanks for that, Bill.
Sure.
Now, if we talk about the movement out of Africa, we now get into Europe. There are species. Would we at this time, we are looking at a little bit to put it into perspective, would there have been about 10 to 12 different types of us, if I could use that word, around before the Homo sapien actually dominated? Are we looking at that number or is there a number?
That's a great question. We don't really know for sure. What we do know is that when Homo sapiens started leaving Africa, it was still a pretty bushy branch of the family tree. There were still other Homo species that were out there. And so Neanderthals are a good example. But also there's Denisovans, these beings that we know very little about that were probably pretty closely related to Neanderthal, but a distinct species that lived in what's now Russia. And we can see Denisovan DNA in people who live over in that part of the world, particularly Melanesians who moved south from there.
Yeah.
We have these hobbit-like species that lived in Indonesia.
That was interesting.
We've got all these. It's super interesting. We've got all these different examples, and how much Homo sapiens ever interacted with them, the only way to know for sure is if we can find either the fossils in close proximity, or better yet, if we can DNA sequence these other cousins of ours and then look for those genes in us. And of course, we've now done that with Neanderthals and Denisovans. We have not done that with any other species because we're not really sure what's out there. If I had to guess, I would say we're going to discover new ones, and your estimate might well be a good number. I don't think we know at this point in time.
And would this also be the time that we now start to develop language? And how did or when did this come about?
That's a great question. I wish I knew the answer. I have no idea. I would say that pre-Homo sapiens, it's probably the case that we were just communicating by gesture, but it's possible that Homoerectus had some form of vocal language. Certainly by Homo sapiens, I believe that we had vocal language from the very beginning of our species, but even that's incredibly hard to demonstrate. Some people have argued that language probably didn't proliferate until we see this explosion of culture, which is within the last 100,000 years, even though as a species, we're more than twice as old as that. So look, it's an arguable point. Eventually, I think we'll be able to find critical genes that tell us how volitional control of the voice box. We'll be able to sequence those genes in ancestral fossil remains, and we'll have a better handle on that. But for now, that's almost anyone's guess.
Right. And we do have an interesting quote where Steven Pinker says that people know how to talk more or less. the sense that spiders know how to spin webs. So he looked at it as evolutionary adaptation and like the eye or probably other parts just designed to carry out important functions. He didn't really see it specific to at a particular time, exactly like you said.
Yeah, because think about it, it would develop over a very long period of time from early gestural communication into slowly adding a few vocal commands along with it until eventually shifting to be primarily vocal. But even now, when we're primarily vocal, it's super hard to talk without moving your hands because obviously those two things went together for so long that we have a tendency to gesture with our hands. I'm doing so right now, even though you can't see me, just because it's an automatic thing that people do.
But I do think it would be connected to some form of introspective thought, or the moment we started getting introspective thoughts and developed the consciousness of oneself. And I think this is all put together that would have happened at around about the same time, where it's language, it's introspective thought, it's the fact that I now started developing some emotions.
Yeah, all those things you're right, they would have developed hand in hand, where a new ability in one domain would produce new opportunities and eventually new abilities in another domain. My colleague here at UQ, Thomas Sudendorf, has a fabulous book called The Gap, and it's the gap between humans and other animals, and he does a really good job of laying out exactly what we know about the science of these different underlying mental processes that are involved in these different abilities, how they come online in different animals, and how, of course, the final version only being in us, and then importantly, how they also come online together in human developments, because small babies can't do these things either, and they only learn to do so as these different mental abilities come online.
And as we would have got collectively together to move out into different other areas, the general number of groups or tribes moving together, I know that the corporate world uses 150 as a benchmark, but I think 150 would be probably a number that once people know what they're supposed to do and they have some kind of a vision, then you can control 150. But if people are moving out into the unknown, it would be a little bit more difficult. Probably a smaller number would make more sense.
You know, you're absolutely right. And so if you actually look at hunter-gatherer human populations, 150 is the biggest possible size they typically get, but that's also a very rare size. It's much, much more common to be in groups of 20 or 30. Right. And so 20 or 30 is a collective that's it's easier for them to come to a consensus. Nomadic hunter-gatherers don't have a paramount leader, and so everybody has to agree. And it's hard to get 150 people to agree on anything. But 20 or 30 people you can get to agree, all right, tomorrow it's time to break camp. We're not finding any food nearby. Let's move along and let's go west. That's the kind of judgment that everybody can sit around at a number of 20 or 30, or even a little bit larger, and come into agreement on. But when you get bigger than that, you tend to get a lot of bickering, and groups end up breaking into subgroups where, yeah, we're going to leave tomorrow, but 30 of us are going to go west, 40 of us are going to go east, 50 are going to go in another direction altogether, and maybe we'll all run into each other again at some random point in the future. But for now, it's just too big of a group for us to maintain.
And this is very interesting. I think this becomes really interesting now because the Homo sapiens are going to come into direct contact with the Neanderthals, and this is probably the first time that they actually meet each other or see each other. So this would have been a defining moment as well for all of us, because it could have gone either way.
Yeah, so it would be super interesting if we knew what happened when they encountered each other for the first time. We do know they eventually had sex, and that's a common thing that our ancestors did wherever they encountered. But what we don't know is how much conflict there was. We don't know if the fact that there are no Neanderthals anymore means that we killed them off. We don't know if we killed them off with weapons on purpose or with pathogens on accident. We just don't know. And so, or maybe all we did was outcompete them. Or maybe when Europe warmed up, their heavy bodies were harder to maintain, and so they just died of the fact that the environment wasn't a good fit anymore. Unfortunately, we just don't know. And so, as you point out, it would have been this very interesting, decisive moment when they encountered each other. And I don't know that it would have seemed as important to them. I think they would have thought, that's an odd looking group I've never encountered before. They would probably think that it's not that they look so funny, rather that they do things differently. They can't understand each other would have probably been the more noticeable feature. But, it's super hard to know how they would have reacted to each other.
And you did touch upon the interbreeding, and would that have resulted in some kind of anatomical variation, which probably, I guess it's about 4 or 5% of max to a maximum that we have of the Neanderthal gene. But what did we pick up from them? Would we know that?
We are starting to sequence and figure out what we've got from them. And so far, the data suggests that light skin is a Neanderthal trait.
Right.
And of course, that makes perfect sense. Light skin would have been a disaster in Africa because you'd have got sunburned.
Right.
But it would have been helpful in northern climates because you could absorb vitamin D from the sun more regularly, or generate vitamin D from the sun. And so that appears to be a Neanderthal trait. Light colored hair and eyes, which go with it, appear to be Neanderthal traits. And then there's some other random ones that are about fighting disease. There's some random ones that are unique to people who live in high altitudes that I can't remember if they're Neanderthal or Denisovan, but nonetheless
Right.
are inherited
No, I think
traits from
that's
these.
Denisovan. You're right.
Yeah, and so it would have depended on the human population where it did that particular trait prove to be valuable for them. And so people who lived in India, well, light skin would have been a disaster. And
Right.
so even if they had acquired that Neanderthal trait, they would have shed it pretty quickly because whoever had it would not be a success. But people who live farther north, that would have been a very useful trait to them, and so it would have been retained.
And also at this time, while this happened, it would have been very, very important for the Homo sapiens to be part of this group, because you don't want to be left alone while you're faced not only with environmental challenges, but new enemy that you had to deal with. So I think being ostracized from a group could that be one of the reasons why we developed that emotionally and have it today? Because people seem to be, with what's happening around, we seem to be, getting into groups, and we don't like being part of no group. We tend to want to be part of something.
Yeah, I completely agree. And if you look back, I think that's probably important even well before then, because once we started throwing stones in our collective defense as Australopithecines, well, now being with our group would have been super important, because if you don't have other Australopithecines around to cooperate with you in your defense against predators in the savannah, you're going to die. And so at least since then, it would be basically a death sentence to be tossed out of your group with no other group to join. And so it is the case that all the primates they'll switch groups under various circumstances, and humans are no exception. We switch into different subgroups and such all the time. But what we don't like is we really, really don't like being alone. Now, it's admittedly dangerous for all primates to be totally alone because you've got no one else helping you look out for predators.
Right.
But it's particularly dangerous for us to be alone because you depend so much on your group for success. You can easily imagine, how would you feel if you were dropped alone in the forest? Well, you'd be super scared that you're going to die.
Right.
But imagine being dropped with 50 of your friends in the forest. Well, even though you don't have weapons, suddenly you're not scared anymore because with 50 of us, we can handle whatever will come our way. That's what it means to be human. We're so hyper cooperative. We depend so heavily on each other that the threat of being left by our group, of being ostracized, is so important that we'll do almost anything to stay in our group's good graces.
It's interesting because I think we can directly link that to what's happening on social media today, because you have various groups, so you have various chats, so you have various social platforms where people, the moment they become a part of this, then it's very difficult for someone from the outside to get into it, or if there is cross analysis, then it can get quite difficult to actually see what's going on. So maybe it is primitive, or it's something that we hold well within ourselves, and now all of a sudden with social media, because maybe social media just enhances this deep down emotion that we have from the past.
Yeah, I think it both enhances it and it makes it very public. And so our ancestors lived in a life where they had no privacy. Our hunter-gatherer ancestors were around each other all the time. And it's very difficult for them to do something that nobody else witnessed. Then we shifted into a world where we started to live in cities, so there's strangers. And so we can kind of have a sense of privacy because people don't know us all the time and they're not always in our business. And now, interestingly, social media has brought us back to that ancestral world where when I say something on Facebook or Twitter or whatever, if people get interested, it could be broadcast to the whole world. And suddenly I've got no privacy anymore. I make a stupid joke. Everybody in the world can pile on me and tell me that I'm insensitive or that I'm racist or whatever, sexist, whatever I am. And I can be punished by people I've never even met. And so it's an interesting way it's returning us to this ancestral world. We're all in each other's business again, and where that group can suddenly become so large that these kinds of things can get literally out of control. So like you say, kind of a magnifying effect.
Exactly. And I think that just talks about romanticism or the noble savage. So probably a dogma where you do hear that people are born good and corrupted by society, but that may not actually be the case.
No, we're born pretty neutral. We've got lots of abilities to learn things. We have strong proclivities, and so we're not a blank slate. We're not just born with anything is equally likely.
Right.
But at the same time, we depend so heavily on learning that I would never want to argue that people are born either good or evil, that
Right.
the original society is either good or bad. We have all of that already inside us. We've got evolved into these incredibly cooperative beings who are kind to each other, which is really wonderful. But we did so in order to make ourselves more effective killers. So
Right.
it's not like evolution wants us to be good. It just wants us to be effective. Want being the wrong term. Evolution rewards that which is effective. And our version of being effective is really lovely. It's being kind to each other, but of course it's also often being aggressive and awful. So both of those things are part of our human nature.
Exactly. And I think it's important for us to understand that identity and activity can be put aside, and a person can disagree with me, but and I could be doing something else, but we should not mix those two things. We could still get along if we have different ideas as well, and I think that's very important for us to understand as we move forward.
Agreed. It's super difficult, though.
Whatever happened with the Neanderthal, like you said, we are not sure about what happened, and it could have been natural disasters. It could have been anything. From there, as we moved forward, I would like to just try to get a little bit of understanding from you, because we do see a lot of group dynamics in play here. But I think at this time, if not a little bit before this, leadership would have been very important, because you are now put in a very critical situation where decisions need to be taken at that time quickly and fast, because life dependent on it for your group and for your tribe. So could we look at it as some form of the evolution of proper leadership, official leadership?
Yeah, so leadership would have been like many other aspects of group living. It's a critically important thing. It would tend to emerge in different ways in different times and places. But those groups that couldn't effectively turn toward leaders when they needed to were going to be groups that were less likely to succeed. Right. And so you have two kinds of evolution there. You've got a cultural evolution, where groups might have leadership practices that are really just determined by their culture and their norms. And those groups that had good leadership practices that were effective in times of conflict and that were likely to help the group survive and extract resources from its environment, those cultural practices would have predominated. And so that's not biological evolution at that level. That's more just good ideas do well and bad ideas don't.
Right.
And then simultaneously, human beings who had the right proclivities that made them capable of being good leaders, made the group likely to choose them, they personally would have benefited to the degree that the group found them valuable. And so we get people often vying for leadership positions. And part of that, I think, is purely cultural. In my society, I'll get more money if I'm a leader, so I want to do that, maybe. But some of those reasons are also going to be evolved reasons, where I want to be esteemed by my group. And one way to be esteemed by my group is to be an effective leader. And so I strive to do that.
Exactly. And definitely any good idea, the couple of things that would be needed for any good idea to thrive would be, logic and rhetoric, and of course good timing, because you can't be ahead of your time, and so or you can't be past the idea. That's definitely. So I get a sense, even at this moment, Bill, that when we talk about humans as of today, and there's no effortless superiority here. We had to really fight. We really had to struggle. There was environment, there were changes, there was movement. So where we got to where we are, it's been a continuous struggle. And does that mean that the fact that, we have these symbolic adaptations of a hero who goes through struggle and then finally at the end of the day, he sees light, whether it's in our social depiction of movies, is also that part of this journey?
It easily could be. I mean, we love stories of conflict, struggle, and resolution, right? And so we love these stories of redemption. What's interesting, though, is if you look at small children, although on the one hand, they love those stories too, children's tales contain simplified versions of this. Children can see what we see, which is they actually will prefer an actor who always wanted to do the right thing because there was no reason for them to do otherwise. Whereas as adults, we admire the actor who has strong reasons to do the wrong thing, but overcomes those with an internal struggle and does the right thing anyway. And so it's part of actually understanding the complexities of human nature and human intention, where we really value those people who overcome these kinds of conflicts and do the right thing for themselves, or particularly the right thing for their group. So in a way, that's an evolved tendency to favor aspects of our world where we see the value of somebody who has the capacity for self-control, who has the capacity to overcome huge temptations to do the wrong thing that might be very selfishly beneficial but not beneficial to those around them. And so I think that kind of universal human struggle that we see is really a sign of our awareness that as humans, there is always a tension between what's in the group's best interest and what's in our own best interest. Often they're on the exact same page, particularly when there's times of trouble or conflict. But often I could be a little selfish and benefit myself more than my group. And so we value those people who don't take that selfish route, who overcome those selfish temptations and do what's in the best interest of others. And I think it speaks to that fundamental conflict that exists inside all of us.
And I think that's why The Lion King is so popular, because it's all about everything that you just said. You've just probably described Lion King, and that becomes so popular because it's reworked in every culture. And there are stories, of course, and on the themes of Lion King, whether it's Hamlet with Shakespeare, it's the same thread of somebody who is realizing his potential over time. And not, though the person is born with it, but everyone's rooting for the underdog.
Yeah, exactly.
And another thing that came to my mind, and I'm just breaking away a little bit from the chronology of us moving forward, we were talking about the throwing, you were talking about how important throwing was. And I can assure you that 1.5 billion people here in India exactly agree with you, because without that, we would not have cricket.
Right. If you look at most human sports, throwing is super common. Admittedly, kicking is also common, and kicking would not have been a way to kill anything other than if you're really captured. But throwing is fundamental in most human sporting games. And also what we see is that when people are small, when you look at little kids, they typically love to throw rocks. They just enjoy throwing things. And again, I think that's evolution's way. If we enjoy doing it, it ensures that we're actually going to get good at it later in life, which of course, if you're going to defend yourself that way, it's super important that you do get talented at it.
And also, it would have depended on, with the throwing would have come practice, and with practice would have come first lessons in teaching, whether it's kids or whether, they do inherit it. But I think at this time, it would be important to start teaching and passing that skill on, right?
No, you're absolutely right. So human beings are the only species that teach in an intentional way, because we're the only species that can understand that somebody else doesn't share our knowledge. No other animal can really understand that, so they're not really effective teachers, even though they have some elements of teaching in their repertoire. But human beings can teach much more effectively by knowing what you know and then shaping your behaviors to match what you don't know. And what's super interesting is that humans can also teach themselves. So I can teach myself through deliberate practice. I watch you bowl the cricket ball and I say, wow, I wish I knew how to do that. And then I try it myself and then that's not quite right. And I watch you again. And it's this process of actually changing yourself through practice that, again, is unique to humanity. Other animals, of course, practice, but they don't do it on purpose. They practice in their efforts to achieve those goals.
And this is important from a teacher's perspective or from an instructor's perspective, is the known unknown of the student, because it's important for you to know where to start or what the student knows rather than going on with what you plan to do for that day.
That's it. That's exactly right. And so if you can't understand what somebody knows and what they don't know, you don't know where to intervene to teach them. But as a teacher, one of the things that I would first do is find out what my class already knows when we start. And so now I've got, all right, here's their baseline knowledge. Now I know exactly where I should be pitching my lessons so that I can latch onto what they know and build from there. And of course, no other animal can come close to doing that.
Exactly. And there has to be a motivation to remember, because, I know you love rock climbing. So I guess when an instructor is teaching rock climbing, then they would have divided it into two parts. One is this is how you strap yourself together, and this is related to safety. You don't do this and you're going to fall. So that becomes very clear as, this is instructive, and that has to get deep down into the learner.
Right. And so you'll notice, even in giving that example, that you tend to explain why you do something. And so as humans, we often will imitate when we don't understand, but we prefer it if our teacher tells us, well, we do this and here's why we do this. But what's so interesting about humans is even if that step's missing, if you do something, you're throwing the cricket ball and I'm like, well, that's kind of an odd motion. I don't see the purpose of that. But I say to myself, you know what, though? You know how to do it and I don't. So there's probably a reason for it. So I better master it and try to have as high fidelity copying as I possibly can, because that will probably lead to the best outcome. And again, another uniquely human trait, this tendency to copy things even when we don't see the point of them.
You also touched on the movement of, I think it was from Africa out through India into, I think it would have been Indonesia and then Australia. And is there some understanding of, if we look at just between India and China, we look at probably not half, but we look at about 4 billion people. What would have been a reason for this particular area to have evolved into having that kind of density? Is it environmental?
Yeah,
is it something that's behavioral?
That's a great question. No, I have no idea. It's so interesting, though, because you've got such a density of people for such a long period of time. Both the Indian and Chinese civilizations are very old. And I suspect that it has to do with the suitability of those areas for agriculture, because you can't have population density when you're hunter-gatherers. Then the carrying capacity of the land is very low. But both India and China are very fertile places for farming. They're both very early places for farming. And for whatever reason, farming must have happened early and then must have happened very successfully, so that the land could carry the kinds of numbers of humans that it has historically there to allow these very early civilizations to develop.
And I think we also have, I'm not aware if you would know about the Bhimbetka caves in a place which is a state in Madhya Pradesh.
No, I don't know
in India. And these particular caves are very interesting because they've got some rock paintings that have been assigned or have been designated to have been about 40 to 50,000 years old. and it has also just been designated as a UNESCO site. So very similar to what happened in France, where we had people moving into shelters. This particular site does tell us that there was, and this is in central India, so it's not on the coast. I mean, I could understand if people are moving along the coast at that time. This is way central. So there would have been movement into higher lands as well.
Yeah, well, there's important Homoerectus sites in India as well from 1.2 million years ago. And so we know that India is a wonderful place to live for our species and has been for a very long time, even before our species. And my guess is that it's because it's an easy place to live with lots of wildlife, with rich land that you can grow things easily there, that it was just a very attractive place for our ancestors to go. And attractive places are going to be places where population density is higher.
Great. So, Bill, if we had to now say that moving forward, if this is where we are now, I would just like to look a little bit at the future. And are we moving towards the singularity, like Ray Kurzweil says? Or what do you think? What is your feeling of, what is going to happen next in evolution? Because we can't be the end of it. So what is going to happen next?
Yeah, that's a great question. And I'm afraid I don't have much of an answer. Lots of people have very interesting conjectures about where we're going. I think in the short term, it's like anything else. I'm better at predicting tomorrow than I am next year, and better at next year than the next century. Right. But I do think if you look at the data, the population of our planet will probably peak at around the year 2100. And then the population will probably start to decline. And so what you've got is a world where as people move to cities, as they get more educated, they tend to have smaller and smaller families, because large families, rather than becoming a plus, become a burden. And of course, as health gets better, you don't need to have more children because you're worried you might lose some of them. You can be pretty confident the children you have will survive. And so what we see is as populations become urban and as they become educated, the world culture is no longer even produce enough children to replace themselves. And so everywhere on Earth is shifting toward a model where the population is going to shrink. Now, that, of course, could change again. But what it does suggest, at least for the foreseeable future, is an interesting world where instead of population rapidly increasing, it's slowly declining. And then the question becomes, well, how do we deal with that slow decline? One thing that I think will help a lot is that we also see the move toward energy becoming nearly free. And eventually, I think it will become essentially free, where you can harvest the sun's energy with robotic devices that require no human intervention whatsoever and power themselves. And so essentially, everyone will have all the power they want without any price. And then when that happens, really, you don't need to work anymore. And so it's going to be a huge disruption to the world where we tend to have these very small families where work is optional. And I have to admit, I have no idea how psychologically how we're going to respond to that kind of world.
Exactly, because you would have to look for some other motivation, and that motivation has to be intrinsic after that, because you would have to find a way that you want to continue or be aggressive. When I say aggressive, I mean be aggressive in a way of further growth. And also...
so what is your reason for living? Why do you, what is it that you do? And right now our reason for living, of course, gets so tied into our occupation, largely because we have no choice. We need to make a living. What will it be like when we do have a choice and we don't need to make a living anymore?
Exactly. And with the advent of technology now, we have already, we are already on that road. So we have already started doing things, or stopped doing things rather, that we would have done a few years ago, because I don't remember more than 4 phone numbers. I don't know if you do, Bill.
Yeah, it's true. It's absolutely true. I remember my number from when I was a kid, but I barely know my number now because it's just automatically in my phone. And so we've shifted toward knowledge that was really valuable being utterly worthless. When I was a kid in mathematics, I had to learn how to use a slide rule, and I was already questioning the value of that because people were making these 4-function calculators. They were admittedly very expensive, but they could add, subtract, divide, and multiply for you. And I was like, well, why would I want to use a slide rule? Nobody even knows what a slide rule is anymore.
Right.
And so lots of complicated things from our past are trivial and irrelevant, and lots of things that were once simple, what underlies them now is so complex that we couldn't possibly replicate them, but we rely on those devices anyway.
Exactly. And I think that the immediate future would be what's going to happen once we get into driverless vehicles or automated cars. Because I think we already have an impact of that in the US, because you're talking about, nearly 40% of the working force as far as trucking is concerned. And they're already talking about using the trucks on the highways or on the freeways. Initially, they may move into takeover from the city, but that still means a reduction for work for a lot of people.
Yeah, and so every time this happens, it's a disaster for the people whose jobs are lost, because That's what they've been trained to do. That's what they know how to do best. And suddenly nobody wants them to do that anymore. And so you've got this momentary disaster. And then when you come out of that disaster, a generation later, everyone's better off. And so if you look, for example, at the history of agriculture, every country on earth, basically 90% of the people in that country were involved in agriculture, and their productivity levels were very low. Now, industrialized countries, only a few percentage of the people are involved in agriculture, and their productivity levels are very high. So agricultural products become cheaper for everybody. Everybody eats better. Hunger becomes less of a problem. But of course, when you're moving all those people off the land who were once farmers, it's an individual disaster for every one of them because they have to find something else to do. So what you want to do as a society is try to find a way that when these massive dislocations come, and you point out an important one that's just around the corner, you want to say, all right, we can see this coming. What can we do to help those individuals who are now, their livelihood has been destroyed? And what can we do to help them find something new that actually isn't going to disappear tomorrow as well, but that's going to fit into the new world that we live in?
And I think because of this rapid change, we all would have to look at a future competency for students, if not for people moving forward, and that would be continuous learning. That probably is going to be something that would have to be officially drafted into our education system.
Yes, and I know it's something else. So I teach here at the University of Queensland in Australia, and we're very concerned about continuous learning. We see that as the next big step that's on the horizon that we as universities should try to find a way to provide, not just to our current students, but really to everybody. And so it's all jobs are likely to change. Some change dramatically, and worse yet, for the owners of those jobs, completely disappear. Others, although, will require new skills. And as you point out, that just means you have to envision your life as one of constantly upskilling yourself or changing the skills that you have. In a way, that's annoying, but in a way, it's also a lovely thing because It's so much fun to learn how to do new things and to immerse yourself in new ways of understanding the world and interacting with it.
Right. And would you think that if there is continuous push for continuous learning, it would have to go hand in hand with something like emotional intelligence, because one has to come before the other, and you prepare somebody to first figure out where they are as a person, understanding themselves, and then getting out to understand what they need to do about changes around them.
Yes, emotional intelligence is becoming increasingly important for lots of jobs where it probably didn't matter much before, where you just interact with your environment. But now, because we have machines who interact with the environment and we end up interacting with each other, the economy shifts much more towards service. Then emotional intelligence becomes something that doesn't just get you ahead with your friends and family, but it becomes something that gets you ahead at work as well. And so I agree with you. It'll become increasingly important. We'll probably become much better at understanding what it is and how to train it, because right now we're not so good at that. But as it becomes increasingly important in more and more jobs, it'll become something that's receiving a lot more scientific scrutiny.
Then I think this would have to be centrally controlled, because like we talk about larger populations, and one interesting question that I always wanted to ask you is, New Zealand, how come a country with that population regularly finds a place in the semifinals or finals? Because it's a skill, and within that group, they do manage to reach that, the high level of efficiency that is needed. Is it because that it's easier in small groups to detect the outlier as far as excellence is concerned and then develop that? Or is it because within larger groups, it's difficult to find the right person?
And that's a great question because, New Zealand punches above their weight in cricket, and they also punch above their weight in rugby.
Oh, yes.
They're supremely gifted in both of these areas, despite being such a tiny little country that the entire population could disappear into a city in India. And so you have to ask yourself how that is. And I think that whatever they're doing, they're really good at identifying interest and talent at a very early age and then fostering that as much as possible. Because I don't believe that they've got more interest and talent in their small country than we have in these larger countries. I just think that they've harvested a lot better. One advantage is because by being a relatively wealthy country, if somebody has those abilities, they're going to get noticed. Whereas you could easily imagine, somewhere in rural India is the greatest cricket player who ever lived.
Right.
It's Donald Bradman cubed, and nobody knows because the kid doesn't get the opportunity.
Exactly. Somebody needs to find him and get to that place.
And nurture that.
And nurture that. And nurture that, exactly. Before we come to the end of this, is there something that you would have wanted to cover, or something that I've not covered, and something that would have, or you want to talk about your book now? Because there are a lot of people, I'm sure,
would be interested in covering. So I don't think we missed any important topics. Of course, the book goes into quite a few areas that we haven't specifically talked about in the time we've had together. But I would say that at this point in time, the key to understand about the book is it really spends about the first 3 chapters exploring our deep past, and how people interact with each other in innovation, in tribalism, in global affairs, it tries to then use those same principles to look through lots of things. And then it ends up with a great deal of discussion of happiness and how we can use this knowledge of our evolutionary past to understand happiness better. It's not a self-help book in the sense of making you happier, but it does try to identify the things in life that tend to make us happy. So with a little luck, those listeners who were engaged by this conversation and might like to further explore it would find lots of these kinds of things of interest in the book.
No, I'm sure, and I can second that because I've been through it. And before you go, Bill, I just want to pick your mind on something that, I don't know, this is something that I've come up with. So it's going to be interesting for you because there's no background to this. But I've come up with something that's called the best friend hypothesis. And I'll go quickly through it. And you've got to tell me whether it's good or whether it's bullshit.
Okay, sure.
Okay. So my idea here is, along with the story that we just spoke about, is the evolution of man, starting from where we started. What I also think about is, what about the evolution of the dog? And so, you had the woodland fox, which lived about 6 million years ago, and it evolved. It is now, that's where the dog actually evolved from, back into wolves. And they say that, and we do know now from what we have, it's about 40 or 20,000 years ago where the dog actually split from a wolf. And probably this is the only large animal that we've domesticated because of behavior. We've not domesticated a dog because of productive value or anything that we get from there. So there would have been some time in the past where hunter-gatherers would have started moving with this wolf. But on the other side, probably the wolf or the dog in the making would have understood that, if I can adapt myself and my behavior and grow these long ears and sleepy eyes, and it may just be possible that I'm going to get a seat next to the king of the universe. And that's exactly something that happened. And in fact, there's a very interesting study in 1959 by a gentleman called Dmitry Belayer. What he did was he tested specifically this. And what he did was with silver foxes. He selected the least aggressive silver fox, and over a period of 40 years, he looked at how they evolved. And later on, with, what we talk about evolution, which could be either, forced evolution or natural evolution, he realized that there's just about the difference of 11 fixed genes between the current wolf and the dog. It can't be due to natural selection. So my thought is have we been played here? Have they just sat on with us and, said, what, we don't need to do all this. We just stick around with this guy. We look nice. And we're going to be sitting in an AC room. We're going to be having shampoo and we're going to be having everything.
Yes, no, you raise a very good question. And I would say that, yes, the modern dog plays us like a stringed instrument. Yeah. But I would say that the ancestral dog earned its keep. And if you think about human abilities and dog abilities, they're almost perfectly non-overlapping and complementary. And so human beings have very good eyesight, but we can't hear very well and we can't smell very well.
Exactly.
Whereas dogs have poor eyesight and hear and smell very well. So here we are, apex predator during the day, but a prey at night. Dogs are not very great predators during the day, but they're awesome at night. So they would have been a great protection for us in the evening when we couldn't see and therefore had to rely on our organs that weren't as good. The second thing that dogs have over us is that they're fiercely loyal and they have their own biological weapons. And so if somebody came into our cave who we don't know and don't like, dogs don't think, I wonder if I can take them on. They just go for it. And so they're going to do their best to protect you. And so they would have been a huge help for our ancestors when they're fighting off animals or other humans who wanted to do them harm. I agree with you that they were semi-domesticated probably by following humans around originally, and then humans would have tolerated those ones that were more useful and not tolerated the ones who were less useful. And so we would have shaped their behavior to a large degree to ensure that we're choosing the ones that are useful for us. But the end result is we've also, as you point out, created these animals who are inherently, to our eyes, adorable and who they bring out our sort of maternal and paternal instincts. And now, as you point out, our dogs do very little other than laze around the house, and yet we're very fond of them anyway. We shampoo them, we feed them. I've got a very small dog who last night in the middle of the night decided she was cold and pawed at me. And of course I raised a blanket and she hops in and warms up. So yes, they take advantage of us in a big way.
Then I think we need that as well.
Yes.
Yes. So, Bill, it's been an absolute pleasure. I could keep talking to you and I could keep doing this forever. But thank you so much for sparing your time, first of all, and talking to us here.
Look, Joachim, it's been lovely chatting with you. I think we've covered a lot of the interesting things that took place over this very long period of time, and I hope that your listeners enjoy the conversation as much as I did.
Thank you, Bill. All the best. To all my listeners here at Indian Genes, it's been an absolute pleasure speaking to Bill, and I'm sure all of you have enjoyed it as well. So we look forward to spending time with you again on our next episode, which should air in about a couple of weeks. And till then, enjoy yourselves and see you back again on Indian Genes.